All right, let's keep going. Just to maybe one or two more examples. We're gonna have the quiz. Okay. Given the following functions, find its derivative. Okay. So this idea, I think you understand, right? Find derivative of hey. Okay. Yes, you can use f of a prime of a, or a here. Doesn't matter, right? Just notation. Notation. Okay. Work as a group. Simplify this. Okay. I'm just plugging. Just plugging. Just plugging. Just follow this formula, term by term. I have that. Okay. Expand that. Simplify. Cancel a bunch of h. Then tell me, okay, what would be the formula? And okay, some of you already know the answer, right? That will be the answer. A good idea. If you don't know how to expand, if you don't remember the formula for this, it's a good idea just distribute that 3 times. Right. If you don't know formula, you should know the formula. No, not really. You should know the formula. You were able to cancel that already, right? Negative x plus x. If you foil distribute, that x cube, there's an x cube in here. X times x cube, a positive x cube from this. A negative x cube here, that also go away. Right? A lot of things go away. Okay, I should have x cubed plus 3x squared h plus 3x x squared plus h cubed. Okay, if you FOIL, you're gonna have that. Okay, and then this purple, which you did this 2 times negative h, negative x cubed, negative h, negative x cubed is this thing. All right, there. So FOIL that or expand this, you have these terms. Okay, then you have the last 2 terms over there. Positive here, negative here, cross out. All of these have h, right? All of these have h. H here, h here, h here, h here. Cancel with this h. Okay, so what do you have? So like I said, a lot of things cancel. That. 1, 2, get that 1, cancel that. So that leave you. Oh, there, the last h. Thank you. That's just negative 1. Thank you. So you have 3x squared. You don't have h on the bottom anymore, so no more fraction. 3sh plus h minus 1. There. Okay. 0, go inside. 0, go inside. Go away. You only have this minus 1. Consistent. So that's basically the derivative. Okay, everybody got that? Okay, now plot this. Sketch this. I'm going to show you that they are consistent. Your answer now. Now, the first half of this, technically the previous section is about finding here to here, 2.1. 2.2 is about finding the sketching of these two. They should be consistent. So x cubed minus x, I'm going to give you the sketch. And again, I am missing the space. I'm going to put the plot here. I'm going to plot it over here, just a mini version. You should buy this. X cubed plus x. X cubed minus x. Very easy to recognize, right? That basically x cubed minus x. And the negative 1 and 1. Okay, will be where you have the flat tangent line. Or the derivative right here, this point, and down here, they will be 0 line, last example. Okay, so now, can you try to sketch the derivative? So this would be f. Okay, over here, sketch f prime. Okay. And when you finish that, it's also represent this one down here. It also will be the sketch of this one. You can technically sketch the first one. I'm gonna draw in here. 3x squared without this is that, right? 3x squared is that. Minus 1 function transformation. Shift down by 1 unit. So that would be your first one. You can use, you can use that. Basically that. The second, let's say prime equal 3x squared minus 1. You can either do that, and these 2 points is negative 1 and 1. Okay, another way, right? Welcome to calculus. That's one part of calculus. All right. First of all, remember this. Whoever told you the calculus is easy is either they fail and they try to make you fail with you. No, right? Okay. Or they some kind of like a descendant of Newton something. Okay, so that either one of those two scenario. A normal person being never say calculus easy. Okay, never say calculus. However, Newton invented calculus when he's 22 years old. By the time he's 23, he already have he already explained how the star, how the Earth, how on the planet moving around the sun. He already calculated the gravity of between the sun and the moon, the Earth. He already calculated that by the time he's 23. Okay, he published most of the work that you learned so far and about to learn up to count 3 is what invented before he turned 23. Okay. Yep. He's still virgin. Yeah. He died for our sin. See? And now we suffer the consequences. Yep, all of this, literally. That is a fact. He got his doctor or something. Yeah, I don't think he take his doctor. He don't even care about his doctor. He just want to, learn things. And he invented calculus because somebody asked him how does sun move around why does the Earth move around the sun? Not in a perfect circle. It's not moving in a perfect circle. It's moving in an ellipse. Okay. Moving ellipse. He go back home. Let me invent calculus to answer that question. He did that actually. Okay. All right. Okay. So if somebody tell you that his calculus is easy, okay. So yeah, maybe he's long lost children of Newton. So don't trust them. Don't trust them. Work with an assumption that is difficult, so you can overcome that. Okay, last thing before we close out is just a notation. Notation, just a different way of writing derivative. So far you learned a few of the notation. Very informal one is the slope, right? The slope of tangent line. Remember, not of anything. Slope of tangent line is one way to express derivative. Velocity is also another way to express. Is the derivative of the distance is another way to express derivative. And then a formal, generally, if you have a function f, then the derivative is f prime. Okay, f prime. Say it out like this, f prime, or derivative of f, that's it. Okay. Another, okay, so those are the things that we learned. This f prime, there's another way of saying is just df over dx. We're going to see this in a little bit. Okay. Throughout this semester, eventually we're going to migrate from this notation to this notation. This notation to this notation. These are the two that I need you to able to familiar. Sometimes you were given as a function, for example, y equal x squared, right? Basically, f, right? Y f the same. So y prime, you can see that. You can do that. You can actually write that. So y prime 2x, right? Another notation. One more is dy over dx. Yes. Okay. In rock school, technically around 400, 500 level, you're going to see this notation. Okay. Okay. But for now, for the sake of our class, you use this notation. And this notation, df over dx, that d something notation, it has a name. It's called Leibniz notation. Leibniz, just the name, Leibniz notation. Leibniz is the name of a French mathematician. Yes, also a very genius, you guys. Back in the day, those are celebrity technically. Back in the day, they don't have. What do they have? They have maybe Shakespeare. That's it, right? Back in the day, it's true. In around 1700, 1600, the scientists are the celebrity. Those the one they actually to go out in the street. They was like hunted by the people, like want to have the auto run and everything. Back in the day, they don't have celebrity. They don't have a lot of singing. They don't have a lot of entertainment. These one, Newton, Leibniz, they technically the celebrity, and that he got his PhD in 17 years old. 17 years old, he got his PhD. Okay, I maybe spend another 7 years. I don't even get my PhD. Leibniz got PhD in 17 years old. True PhD, right? So yeah, true celebrity. Okay. Let's close out here. We're going to continue on Monday. Let's do a quiz. Okay, let's do a quiz. Before we start.